So you can monitor battery charges on anything between 10 and 200 volts and a max of 20 amps. That's pretty cool. It's been a while since I've done a video about batteries. Now this one's going to be a bit more in-depth, a bit more technical. So there's two ways you can look at this video. One, either it's just good information about how batteries work. Two, if you're really into DIY stuff and repairs, or a bike shop that does repairs, maybe this is something you can look at as actually some hands-on technical training. But this is my disclaimer. Don't do anything you're about to see on camera as far as disassembling batteries if you don't have experience with this stuff, because lithium-ion batteries are still dangerous and flammable. Now, with that out of the way, let's try and fix some batteries. So I have quite a few customer batteries here that are in some sort of disrepair. They were brought in because they don't work. And what I want to show you is just the basic troubleshooting steps we do, and then some more advanced tools that we use to diagnose or test batteries. Now, there's a few things that are off-the-shelf items you can buy, and there's some custom stuff that I've made, but we'll go over all of those. Just a brief intro as to what I'm going to show you. This is the cycle satiator. This is kind of like the best e-bike charger money can buy, but they are expensive at about 300 bucks. But very useful because you can measure capacity as you charge batteries. Highly recommended, despite the high cost. I needed a higher voltage system to test, and that's what this all is about, which I'll explain how that works in a little bit. But let's take battery number one, open it up if we need to, hopefully we don't, usually we do, and show you what do you do if your battery just doesn't work. So battery number one, it looks like is, I think, a 60 volt. This is off a Zoomers. I think this is some sort of scooter. Everyone is assembled a little differently. They all have a BMS. That's the safety circuit that's inside. But then they can be different as far as, do they have fuses? Do they have things that trip? We often don't know till we take it apart. So step number one, and probably the most important one that's often missed, don't assume that your battery is the problem. Often, it's the charger. So first thing to do is plug the charger in, take your multimeter, set it to the voltage setting, DC voltage setting if needed, and we see what do we get out of the charger. There you can see this charger is outputting 67 volts. That is what we want for a 60 volt nominal battery. So good sign for the charger on this one, bad sign for the battery. So now on to step two, we got to check the voltage at the battery. Now the first thing you want to do is look and see if there's any sort of switch on a battery, of course, and turn it on. You'd be surprised how many times I've seen people think their battery's dead when it was just off. Now we have some points right here. There's no on-off switch, so we don't know which one's positive and negative, but it's not going to matter to our meter. It's either going to read negative or positive voltage and give us a number. So I'm only getting 2 volts on this battery. Not a good sign up to this point, but that is so low. There's either one of two possibilities. Well, there's more than two, but here's the most likely things. Either the battery really is that dead, and there's some cells that are dead, we'll find out in a bit, or maybe there's just a broken fuse or bad BMS, so it's just not getting the voltage out to the port right here. But we're reading something, so there is some voltage somewhere. The best thing to do when you start opening any battery is be extremely careful, treat all wires as if they are live, because these things will shock you. You're laughing over there, but that is said from experience. Looks like I'm just seeing a few screws on this end that we need to take out. And then hopefully this kind of slides out. Like I said, I've never worked on this specific battery. Now another thing I will mention, I'm going to be very careful about this as I'm working on these, is to avoid making any contact between any positive and negative terminals. So this is a metal table, so I'm very careful about where I position batteries when I'm setting them on this. If I have things that are more open, then sometimes I'll put down, even if it's just a piece of cardboard or something, just to make sure I'm not having a contact. And you gotta be really careful with your tools as well. If you really want to get fancy, you can buy non-conductive tools. You also can buy big, thick rubber gloves that do not transmit power to avoid getting shocked. So, not absolutely necessary, but good safety items to have. Okay, we pulled all the screws out. Looks like this is just gonna pull right out. So this is a good sign for repair. We have an XT60 connector here. Makes it easy to troubleshoot. We can clip this off, check voltage here. We also have a little fuse box right here. Maybe the fuse is just blown and that's why it's low. There's a chance. So because I know I don't really have much voltage here, I'm basically just gonna go from one thing to the next to find out where does the voltage stop or start. Now we have clear positive and negative. Negative is always going to be black. So you can see we're still getting 1.9 volts on the meter there. So it's not this connection. We know this is most likely good. It looks clean. There's no burn marks or anything suspicious here. Everything's soldered nice and tight. So we're going to assume that connector is good. Now we can pop open the fuse block here. Oh, that's tight. Normally, these are things you can just pull right out. These are automotive blade style fuses. And this was very hard to pull out. And if we look real closely, there's a lot of blackened spots on it, a little bit of melting. This fuse got hot and looks totally dead. This could be our problem. Now, we can confirm that right now. What we can do is put our positive probe right before the fuse that's in line here. Put our negative probe on the XT60, and look at that, 63 volts. So I got lucky with this one. This is an easy one. All we gotta do is put a new fuse. The stock one was 40 amps, it blew. Now if you're wondering, why did the fuse blow? Maybe it sustained close to maximum current for too long. Maybe they just pulled a little bit too much current at a brief spike at one point in time. You know, it's hard to say without having the rest of the scooter or bike here, but the fuse did its job, which was to blow when too much current was going through it. So that's a good thing, and thankfully, easy to fix. All right, I found a new 40 amp fuse in the toolbox, thankfully. Pop that cover back on. Now, it's always a good idea as you're reassembling things to just go backwards and verify that things are working. So I've got 63 volts here. I'm gonna plug this back in, check to make sure I have 63 volts on our output now, which we do. This had a little zip tie around the XT60. That's so it can't get unplugged by vibration or anything while riding. So we're gonna put a zip tie back on there. Last step with this one, now that's all reassembled, is verify that it charges, which it does. I'm gonna assume everything is good from here. We know the battery's a few years old. We could do a capacity test if we wanted to, but customer didn't ask for that. They just wanted the battery to work again. So we're done. Let's move on to the next one. Customer states not charging. So as usual, we're gonna check the charger. Yeah, we're getting 54 volts, which is exactly what we should be getting. Let's plug it into the battery. So no red light, it's not recognizing a charge. We do have an on-off switch right here. It's in the on position. So with this type of battery, since it doesn't have the cradle, we can just check right down here on the pins and verify if we're getting any output voltage. And we are not. Basically, it's time to open it up. So we've got a lot of screws to pull out, but this is a pretty standard battery style. Some of these batteries will have a fuse holder underneath. This one, unfortunately, does not. I will point out that there's 2 screws right here. You do not need to remove those. Those are part of the lock assembly. So that's just gonna cause you trouble later, so leave those in. Just do these small ones around the perimeter. And now we pull this off. Now from here, we can kind of do the same thing I did on the last battery. Now we know we didn't have voltage going to the output right here. Everything is soldered on tightly, it's connected. So let's move on to this XD60 right here and see if anything changes. I'm gonna guess no, but you never know. And nothing. This is a plug for our charge port. It's pretty safe to assume nothing going on there. We do have a switch right here. Now it's important to note that when there's an on-off switch, that turns off or on the BMS, and basically if that's off, the battery won't turn on. So this has an on and off position, so we can turn our meter to continuity setting, so we get a nice beep when it's connected. Leave the switch in the on position and see, is the switch working? And it is, so we can eliminate the switch as the problem, but we do need that in the on position for this battery to turn on. We're gonna have to come out a little further now. And thankfully, this one was not glued in like some, so it was easy to get out. This plug just goes to the external lights. We don't need that for anything to turn on. So at this point, we should have power here with that switch on. We're not getting that. Unfortunately, that means we gotta open the shrink wrap right here. So this battery is gonna be a bit more in depth. So this is just large heat shrink, which I have extra heat shrink around here for wrapping these back up when I'm done. Right off the bat, this isn't a good sign. If we look closely here, you can see there's some rust and corrosion right there. So there's some moisture inside of the battery. It's not really what you want to see. Oh boy. And that was the good side, apparently. It just gets worse over here. This looks really bad. So this battery has a lot of corrosion in it. Obviously has gotten wet at some point, unfortunately. So at this point, it's pretty safe to say, I think, that some of these cells are gonna be dead. But we don't need to check at the cells themselves. The only thing we really need access to is this BMS plug. So all the BMSs are gonna have a plug with a whole bunch of little tiny wires going to it. This is what we wanna unplug, and I will show you how to test this. Now you still wanna be careful not to touch, like I said, any live wires or connections. Just because the battery is reading almost 0 volts at the output doesn't mean we still don't have a lot of voltage in this pack. This could be sitting at 40 volts still possibly at some point. Now that I have the BMS cable exposed, you can see there's a black wire here, red on the opposite side, white in the middle. So this is measuring the voltage of not only the entire pack, but each cell group. So if we check here, we can see what are we getting. And you can see there now on the meter, we actually have 26 volts. So not anywhere where it should be, but it's close. So this is lithium ion. We should have nominal 3.7 volts per series of cells. So if we just put the black probe on the negative side, we can just go one at a time with each group and check what voltage we have. And group number 1, we should have 3.7 volts. We have 0. Group number 2, 0. Group number 3, 0. Group number 4, 0. Number 5, we got half a volt, which is basically anything under 2 is unrecoverable. So that's dead. Now we got 3.68. So there's a few cells that surprisingly are still healthy. 3.7, that's pretty good. 3.7, that's not bad either. 3.7. 0.2, there's another bad group. 3.7, 3.7, and finally 3.1. So what we've got here is very poorly matched cells, a lot of corrosion. This battery is toast. It is not worth rebuilding. There's far too many bad cells, even just a few cells. It can be very difficult to match and repair, so I generally don't recommend it. This one is just not, this isn't good. This is just bad, corroded. At this point, this thing is just ready to be recycled. So unfortunately, bad news for the customer, but that's what happens. If you leave your bikes parked out in the rain or hose it down, obviously somewhere along this bike's life, it definitely got wet. Now, as far as disposal goes, here in Grass Valley, our local waste management at the dump, they do take lithium batteries. So for free, you can take them there. They have a special spot for them. They are a hazmat item. You cannot throw things like this in the normal trash. So please don't do this. Please take them to wherever the local recycling waste center is. They should have a spot for these. Next, we got a 52-volt juiced battery. Description from the customer. Battery says it's fully charged, but it's not when plugged in. So the juiced battery has an on-off switch on the top right here. It does turn on, and if I check the voltage, the good sign is we do get 51 volts or so, but this should be at 58 volts fully charged. So here's a good time to test out our cycle satiator, or I can also show you how the PID zoom device works. We could even use both in conjunction with each other. So most e-bike chargers just have a on, off, basically a light that turns red or green screen. There we go. But the cycle satiator has a display that tells us what the voltage is currently, what the charge rate currently is. So just by plugging one of these in and telling it to charge, we can learn a lot about the state of a battery. Now, the other cool thing is you can program these to a bunch of different battery voltages and currents. So I can set this for a 48 volt, 52 volt, 72 volt battery. It's compatible with all of those. So I've got it set to 58 volts, which is the max charge of a 52 volt battery, 3 amps, which should be a healthy charge current, and I'm going to tell it to charge. Looks like it's charging right at 3 amps, which is exactly what it's supposed to do. But of course, I forgot to check the customer's charger. So while I'm letting that battery charge for a minute, let's plug this in and see what happens. Oh, that could be the problem. So I'm getting no lights on the charger whatsoever. So it looks like this may be as simple as a dead charger. Yeah, no voltage at all. So we got lucky on this one. This is going to be one of the most inexpensive fixes. All he needs is a new charger and he'll be set. Now, unfortunately, because this charger doesn't work, I can't show you how this PID zoom device works with a stock charger, but let's pretend like the stock charger was working. Now, these come with a XT60 on each end. You've got the output, which is going to go to your battery, the input, which is going to come from your charger, and they have a couple of different versions of this device. I bought the more expensive one, and it's real tiny letters down here, but this has a voltage range of 10 to 200 volts and 0 to 20 amps. So you can monitor battery charges on anything between 10 and 200 volts and a max of 20 amps. That's pretty cool. So all you would do is plug in the appropriate adapter. In this case, the juiced bike uses an XLR connector. And again, we're pretending like the customer's XLR connector works. Actually, look, I have another 58 volt charger right here. Let's use this. Oh, good, this one's got a light on it. Okay, so we're gonna plug in to our charger, and automatically this device is going to turn on. So you can see up here, we have input voltage, 58 volts, output 58, and right now we don't have our battery plugged in, so no output showing yet. And then you can have a set voltage. I was using this for a 48 volt battery, so that's why it's at 54. Let's change that up to 58. There, we'll set it at 58.6. Now what's cool is you can also limit the current. So we can set this to 3 amps. You can also set a timer. So instead of using a smart wall plug, you can have a timer so that your charger is plugged in. If you want it to stop charging at a certain time, you can do that as well. And then when you're ready, you press this output button and it's going to change the output. So we're at 0 volts, put on. So all we need to do is plug this into this juiced battery now. So there we go. Now we can see we have 51 volts. So that's where the battery is sitting at right now. Our set point is 58. So it's going to charge all the way up to 58 volts. We can see the time that has elapsed here. And we also get the max current. Now we're only getting 2 amps because that's all that our charger is capable of. Up here, we can also see the wattage. So we're running right at 100 watts. Makes perfect sense for a 2 amp charger. That's exactly right. But what's even cooler below that is this right here. See, this says 1 watt hour. So this is how much power we are feeding into the battery. So you can use this device not only to check the battery's actual voltage, set your charge rate, set your max voltage. So for example, if you want to set your battery to charge up to 90% or 80% for longevity, you can do that. But you can also see what the battery capacity is. So if you drain your battery all the way down and kill it, which is just about where this is, and then just let this charge, we can see the watt hours we've put back in, and then you can do the math, voltage times amp hours to get your watt hours of your battery. What should it be when it's brand new, and where is it now? So that's going to give you the health of the battery over a full charge cycle. Very, very useful information, and this device, like I said, is much more affordable than the cycle satiator over here. I think it was like 70 bucks for this higher voltage version. The other lower voltage goes up to like 150 volts still, so that's going to be more than enough for most people. I went for the higher voltage version because I get all sorts of batteries that I want to test. So amazing little device, lots of little adapters and connectors, so you can make this work with any charger or battery basically. Very affordable, very smart. Again, these come from PidZoom. I'll put a link to these in the description. They are sponsoring this video. They sent me this device to test out, but now that I've used it, I would recommend this to anybody. I use it all the time for troubleshooting, for testing bikes. If you're into monitoring the battery health of your e-bike, this is kind of a no-brainer. So we might as well just leave this one charging for right now, since we found a compatible charger and I have this device. We'll set it aside, let it go for a little while, and check on it later. Oh yeah, it has a nice little user manual to go through all of these functions, but it's pretty self-explanatory from the screen, but just so you know, it does come with instructions. All right, what do we got next? This one says, capacity test. So it looks like we're gonna have to get into the more technical stuff now. One of our testers up here. So first, let's check what this is supposed to be. This is a 48 volt, 15 amp hour battery, or about 748 watt hours. It's actually 15.6 amp hours. So customer asked us to do a capacity test. I'm going to show you what that entails. First, we're going to use our cycle satiator since our PidZoom device is in use right now. We're going to plug this in and see what is our charge level at. What voltage are we at? And we're at 51 volts or so. So relatively low. So there's a couple of things we can do here. For the most accurate results, I like to do 2 tests, a discharge and a charge. Now, ideally the numbers should come out the same, But the idea is we measure how much power we took out of the battery and how much we put back in. Now we need two different devices to do that. The cycle satiator can measure how much power we put in. The PID zoom device can also measure how much power we put in, but this is where we need something else to measure how much power came out. Now in a perfect world, we would have a nice XT60 or some sort of connector that plugs into this, but this isn't a perfect world, and we don't have that for every battery. Sometimes we gotta do slightly sketchy DIY things, which is what we're gonna do right now. So we have a little connector. These are soldered and crimped basically into blades so they can fit into this style of battery. We're going to check our positive and negative terminals here. They are labeled, but we are gonna make sure they are labeled correctly from the factory.
And funny enough, about a week after I filmed this, we actually did find a battery from the factory that had these reversed, so it can happen.
So here's what we're gonna do. We're gonna shove our little terminals into the discharge end of the battery, and that's gonna be our XT60 that we can plug this extension into, which is going up here to this device. Now this device mounted in this little case, and this one mounted up on the wall do the same exact thing, and I'll explain how they work and how that's wired in a moment. But let's plug this one in, get it discharging. So we want to basically kill the battery, and because we're already kind of low, and then do a full charge, measuring it back up. So when we plug this in, nothing happened. Why nothing happened? It's in on position. No, maybe it's already cut off. Maybe it already thinks it's dead, which would be unusual. Maybe it can't handle the load at all. Well, we're not getting any voltage at all, which makes me think that maybe this battery can't handle much of a load, which is a good possibility because they did want us to do a capacity test, which makes me think the battery was not happy and not working properly. We are getting it to charge. Well, I guess we're gonna have to come back to this. So here's what we're gonna do. We're gonna charge it up, and then we're gonna see how much we can put in on a full charge on this battery based on the cycle satiator data. So PID zoom is measuring the juice battery. Cycle satiator is measuring this one. Once it's fully charged, then we'll come back to this. I may have to plug in a different battery just to show you how that works. So this battery just finished charging, at least it thinks it has. I couldn't even get anything to discharge, and if you can read that, it only put in 2.88 amp hours. That's not a very good sign. So now I'm gonna try and do the discharge test, see if we can even get this thing to turn on. All right, it's the moment of truth. Cannot even get the screen to turn on. Not even a flicker. All right, let's check our battery voltage again, now that it thinks it's fully charged. And I'm oddly only getting 1.8 volts. Let's check the charge port. I got 54 volts at the charge port now, but absolutely nothing really useful on the discharge side. I guess that means I'm gonna open this one up and see what's going wrong, because we didn't get a full charge. We're not getting any output voltage now. There's something definitely wrong inside. So with these batteries, you've got two plastic end caps, one top and one bottom. So we got 8 screws in total to pull out. Sometimes there's a fuse on the discharge side, sometimes there's not. So there's the rat's nest of wires inside. We do have a fuse right here. The fuse has some scorch and burn marks on it, kind of like the one earlier today, but the fuse itself appears to be good. So strangely enough, the fuse holder does not look like it's in very good shape. Kind of makes sense. This is a 50 amp fuse, and this battery is definitely not capable of 50 amps. So 50 amp fuse, which makes no sense. The fuse should not be in that high. This is probably an e-bike that has like a 20 or 25 amp controller. No idea why you'd have a fuse in there that high. Maybe somebody replaced it. Oh, look, it didn't even come out. It came out in pieces. So what I'm going to do is check with the voltmeter right here before the fuse, check our negative side. So if I put the probe here, I get 54 volts. And if I put it here, so we're going to swap that out, see if that fixes our problem. That might be the second fuse today that's dead, but failed in a different way.
So I swapped a new fuse in, a new fuse holder, and everything worked great after that. That was actually a pretty simple fix in the end.
I actually jumped forward a few days now, but just to give you an update on some of those batteries I was testing. The one I was doing a capacity test on turned out to be, yes, just fine. The charger was the only thing that was bad. However, I do have these two juiced batteries right here. One of these, a customer brought in, wanted us to check because he said he wasn't getting the range he expected. He only had 5.5 amp hours going back into this 13 amp hour battery. So that's obviously not very good. And this one is supposed to be as well a 13 amp hour. It's getting about 7.5 amp hours. Now both of these are several years old, but obviously these are on their way out. Now you can do these tests by discharging the battery completely on your bike and then using one of those two devices I showed you earlier, either the PID zoom or the cycle satiator, and measure the amount of battery capacity you put back in, or you can also measure it on the discharge side. So that's what we're going to jump into, is this device up here. Now I mentioned that I have two of them. This one is for lower voltages. This works theoretically up to 72 volts, but kind of gets a little bit too warm and hot. So it's better suited for batteries up to about 52 volts. This one, however, I have geared for higher voltage batteries. So this one's really great for 72 volt batteries, or what I'm gonna show you some tests on today is a zero battery. This is a 11 kilowatt hour Zero S battery from 2014. This is what came out of the motorcycle that's behind the camera over here. So I want to show you how to do a couple different types of tests with this device. One is the long-term test where you do a full discharge, measure the capacity. Another test is something you can do basically instantly. It only takes a fraction of a second and can actually tell you if a battery is good or not as well. But you do need a little more information. It's a little more technical, but let's get into both of those. So let me break down what you need to set one of these up. So the main thing you need to buy is this screen up here. On this, there's a different version on this battery tester, but basically they do the same thing. These are actually very inexpensive. You can buy them on Amazon. They're like 20 some bucks. And they come with this device right here. This is a shunt, so it can measure basically the current across here, and this can measure basically by using the shunt anything from voltage to current to wattage, and actually track the kilowatt hours that you put into, or in this case, out of a device. In our case, this is a battery. Now, just for safety, I have a breaker. So this is our monitoring device. These come with a schematic that shows you exactly how to wire it up. So I'm not gonna go into detail on that, but I'm just gonna give you the basics of how it works. Again, breaker is basically my on-off switch, and then you need a battery. I have this one wired up to an XT90 connector, and then I just make adapters to plug into whatever I need from there. So you need the battery, the testing equipment up here, and then you need a load. So anything that runs on DC power within the voltage range you're gonna use that can draw power. So for my load devices, I have two really large resistors. These are 10 ohms, each rated for 1,000 watts, and they're run in series. So basically I've got 20 ohms, and that is a fixed resistance, which means then we can calculate all sorts of fun stuff from there. But the main thing is we just need something that draws power from the battery. This is something that's a known amount. We can calculate it, and we can make it work with a pretty wide range of battery voltages. Now, I mentioned this works for 72 volts and up. For this setup, my zero battery here has a nominal voltage of 102 volts. At full charge, these things are 117 volts. So there is a lot of voltage potential right there between those terminals. You got to be very careful working around these things. So what we're going to do now is take our XT60. I've basically hooked up some ring terminals to adapt onto there, and then we just need to plug it in, and now that turns on the screen. So you can see we're drawing 612 watts. There's our voltage in real time. That's the current, and then we can measure how much power has been drawn out. That, of course, we can reset for fresh testing. But I'm not even going to do a full test. I'm going to show you how to do it the quick way with math and science. And for that, we need a little formula right here. Basically, what we want to find out is the internal resistance of the battery. Every battery cell, if you know what cells are in your battery, you can find a spec sheet and you can find out what the internal resistance of each cell is supposed to be. What happens as batteries degrade is the internal resistance starts to go up. So by measuring the internal resistance, you can actually see if a battery is in good condition or if it's failing. The only caveat is you have to know what cells are in the battery so you know what numbers to look for. Now I've scribbled down some numbers here for the 0 cells. They use these phoresis pouch cells, and these have an extremely low internal resistance. So these numbers aren't going to work for an e-bike battery, but I'll get to that in a moment. But if we measure somewhere between 8 to 20 milliohms of resistance for the entire 11 kilowatt hour battery pack right here, that would be a good number. I'm going to tell you right now, I've already tested this. That's not what we're going to get. But I'm going to show you how to do it, show you what I got, and how I know that this battery just can't perform like it should. So 8 to 20 milliohms. But how do we know what this number is? Do you just stick up a voltmeter to the battery pack and measure the resistance? No, I wish it was that simple. You can't quite do that. So the formula is that the resistance of the battery, internal resistance of the battery, equals the basically no load voltage minus the load voltage divided by the current. So we have to apply a load to it, we have to measure the current, and measure the voltage in those two scenarios. So let's do test number 1. We're going to hook up our probes right here and here, put this down to here. There you go. Now you can see what voltage I'm seeing. So I'm just putting these onto my terminals here. You can see 111.2 volts is what we're getting. That's basically our resting voltage. That's what we're getting right now with no load. So next we use our tester to draw load. Now you want to do this very quickly, actually only like a fraction of a second up to maybe like a few seconds at most. You don't want to have the battery running for a long time. You want this to be a very quick measurement. So we're going to turn the breaker on, get that measurement, and that's the number we want, like quick. If you wait longer, it changes the results. So faster you measure this, the better. Breaker on, positive connector, 110.7. Boom. So that's the number we're going to write down, 110.7 volts. Because we have our tester up here, we know that the current, we're running about 5.46 right now. Is that 5.47 when I first looked up there? So we're going to write down 5.47 amps. Now we just do some math, which I'm going to use a calculator for. So again, 111.2 is our resting voltage minus 110.7. We get a difference of 0.5 volts. Pretty low voltage drop, but we're only drawing 600 watts, I can turn that off now, from something that's intended to draw like 40,000 watts when it's on the bike, so no surprise there. So 0.5 divided by 5.47. All right, so based on that test, I get over 90 milliohms, if my math is correct. And unfortunately for this battery, a good number would be more likely around 15. Now, I'm not surprised, this battery is over 10 years old. The prior owner told me that it wasn't performing as well as it should have been. And I have actually gone through the individual BMS leads and done some voltage testing and tried to do some resistance testing. And it just seems like my resistance numbers are very high compared to what they should be. So that's why I'm building a new battery pack. But that shows you there is a quick way to do a battery test. But again, you have to know what cells are inside. Now, if we just go with any old generic e-bike cell, either 18650 or 21700, just as a ballpark, say for a 48 volt battery, somewhere between 50 to 100 milliohms of internal resistance would actually be pretty normal. So internal resistance of those types of cells is just higher than the pouch cells that are used in this battery pack. 50 to 100, yeah, this is a fairly easy test you could potentially do if you can hook up a load to your battery. That'd be a good number. Your battery's probably healthy. If you get something over 100 with a typical e-bike battery pack, those cells are probably on their way out. If it's 200 or more, definitely that pack has a lot of age. It's not going to perform very well, and it just needs to be replaced. So hopefully that was helpful. Again, this whole circuit, this is very inexpensive. For me, the most expensive part was actually the resistors. If you find something cheaper to use as your load device, it just needs to be something DC that can handle whatever battery voltage you intend on using. You could definitely find something cheaper than these resistors. I just like these because they're robust and they're a very known quantity of power that I'm going to draw. I'll put some links to all of these different parts in the description of this video. And again, thanks to PidZoom. They are the ones that sponsored this video. They sent me that product for free. I do think it's one of the coolest things I've seen for e-bikes in quite a few years, because it takes any old e-bike charger, a dumb charger, if you will, and turns it into a smart charger. So if you don't have something like that or that sort of function, I highly recommend it.